Perhaps one of the most recognizable physicists, Michio Kaku, has discussed his appraisal concerning this issue. Kaku, known for his surprising contributions to the fields of actual science, has recently acknowledged that the James Webb Space Telescope has found 6 colossal vast galaxies that scientists once thought couldn't exist. These discoveries have the potential to open up new perspectives on how we might interpret the universe. It is, therefore, both entrancing and worth watching out for these developments. Kaku is an eminent figure in the scientific field, a physicist of American and Japanese legacy. He is seen as a specialist in both conventional experimental physics and quantum mechanics. Unlike a few more conservative and cautious researchers, Kaku doesn't belong to that group and has been open to the shocking later discoveries of the James Webb Space Telescope (JWST) mission. We are lucky that this distinguished scientist has chosen to end his silence and share openly what can no longer be denied. The excitement and almost universal tone of the famous physicist is evident in his comments on the discoveries made by the James Webb Space Telescope. He suggests that these discoveries have been the catalyst that has fueled his interest. Let us investigate the implications of Michio Kaku's revelation of these 6 immense galactic systems. Kaku is a researcher who has always been able to explore new theories throughout his life. He understands that Einstein's theories of relativity and Newton's laws are insufficient to capture the full complexity of the universe. Kaku acknowledges that the discoveries of the new telescope could indeed improve the scientific field, despite the fact that many of his peers have not been able to embrace this view. This has caused concern and unease among both defenders and critics of quantum mechanics. Nevertheless, this valid knowledge elicits laughter from Kaku. The JWST has uncovered the discovery of 6 gigantic galaxies, tracing back to the earliest stages of the universe. Each of these enormous systems contains more stars than our own, despite forming only a short time after the Big Bang. The group of cosmologists who made the discovery has named these remarkable systems universe breakers, as their existence could change our entire understanding of the universe. Something here no longer fits with the theory of the Big Bang. The Big Bang theory tells us that the universe was a chaotic place following the initial event. The first solid objects took a few 100 million years to form, and it required countless additional years for these objects to reach a sufficient density to emit light. The development of complex structures like galaxies was thought to happen much later. Some of the newfound systems exceeded the size of the Milky Way, and their enormous brightness suggests that they were likely forming many new stars regularly, whereas our own galaxy forms stars only intermittently. It remains unclear exactly when the first galaxies formed. Scientists have been unable to determine this until recently. The one thing that is clear is that initially, there may have been only single stars or groups of stars that eventually came together to form progressively larger structures, eventually leading to the development of dwarf galaxies, which underwent mergers and progressively grew, as suggested by previous theories. According to these theories, highly advanced and massive systems could not have existed at that time, which raises a question of whether the universe is actually older than previously thought, or whether complex, large-scale structures existed much earlier than anticipated. This situation is challenging for conventional science, which still struggles with this model. Moreover, some areas of physics have strongly rejected this discovery, pointing to potential errors in the age calculations. Kaku, mindful of this, had this to say: "There are many instances of old and misleading theories that stubbornly persist due to the prominence of certain scientists. Many of these theories were eventually disproven when fundamental research exposed their inaccuracies. Thus, the key work in any science, especially in physics, lies with the experimentalists who maintain the integrity of research through observational truth. In fact, on Earth, we have almost no information about the true origins of the universe. The theory of the cosmic explosion, known as the Big Bang, was established in 1927 based on observations of the universe's expansion. This data led to the conclusion that the universe began from a singular point and has been expanding ever since. At the time, it was difficult for people and scientists to imagine a universe with both a beginning and an end. The possibility of a universe that had always existed and was boundless in time was beyond human imagination. Even today, scientists still face difficulties in grasping it. Nevertheless, it is crucial to reassess these possibilities. These new insights do not fit at all with what scientists have relied on for so long in the Big Bang theory. But science has repeatedly shown that reassessment and openness to pivotal ideas are key aspects of the scientific process, just as much as the confirmation of specific hypotheses and observations. When Einstein was a child, it was believed that the stars and planets were fixed in the universe, and that these particular arrangements occupied a defined space. However, we now understand that everything in the universe is moving. Planets orbit stars. Stars move within their galaxies at different speeds, and entire galaxies move swiftly through space. The ultimate fate of the universe is still something we cannot predict. Today, scientists are challenged to accept uncomfortable insights, and it is understood that hypotheses are not simply theories or key insights until they are thoroughly tested or confirmed by careful observations. The concept of the Big Bang arose from the observation that galaxies are moving away from each other, and this distance is proportional to their separation from Earth. This observation, known as Hubble's law, suggested that the universe has been expanding for quite some time. Additional evidence, such as cosmic microwave background radiation and the redshift of light from distant galaxies and other astronomical objects, appears to support this theory. However, it is important to remember that those who once believed the Earth was flat and that the sun revolved around us also had similar kinds of evidence for their doubts, until events or technological advancements provided a clearer and more accurate picture. Similarly, today, we are seeing a comparable situation. Researchers expected the JWST to confirm assumptions about the Big Bang, but instead, they have discovered 6 galaxies that appear too large for their age. This reminds us that science is always evolving, and researchers must remain open to new discoveries and reconsider existing theories in light of available evidence. Scientists use redshift as a tool to determine specific measurements in the study of the universe. Redshift, also known as the Doppler effect, refers to the change in the color of light as the light source and the observer move relative to each other. To understand this, imagine watching a car coming toward you. As it gets closer, you hear the engine growing louder. However, once the car passes or moves away, the sound changes. This is because the sound changes as the car moves. Similarly, with light, when a light source, such as a distant star, moves toward us, the light we see shifts toward the blue end of the spectrum. Conversely, when the light source moves away, the light shifts toward the redder shades. This phenomenon is known as redshift. Physicists have converted redshift values into velocities and distances for measuring quantities in the study of the universe. However, it is crucial to note that small errors in these measurements can have significant consequences. The measurement techniques used in the past are now under review, and the results that researchers will arrive at concerning the latest discoveries related to our universe are captivating. It is important to consider whether these results are truly based on redshift errors, or whether some researchers are simply denying the facts. This is a question that requires serious evaluation and careful review of the data and methods used in the research. As scientific inquiry progresses, discoveries made by instruments like the James Webb Space Telescope often challenge our assumptions about the universe. The new discovery of 6 massive galaxies dating back to the beginning of the universe is one such example. These galaxies, which defy conventional theories of galaxy formation, raise significant questions about the timelines and processes associated with the development of large-scale structures. The James Webb Space Telescope, a successor to the Hubble Space Telescope, is equipped with cutting-edge technology that allows it to peer further into space with remarkable clarity. Its ability to detect light from the farthest reaches of the universe gives astronomers a window into the past, enabling them to study galaxies that formed billions of years ago. The discovery of these ancient and massive galaxies challenges existing models that predicted such large structures should have formed much later in the universe's history. The implications of these discoveries extend beyond cosmology and into the realm of fundamental physics. compelling scientists to reconsider established theories about the early universe. These revelations also highlight the importance of remaining open to revolutionary ideas and adjusting our understanding in light of experimental evidence. Kaku has stressed the critical role of scientific proof in shaping our understanding of the universe, noting that hypotheses must continually evolve to accommodate new information. The debate ignited by these discoveries reflects the dynamic nature of scientific inquiry. On one hand, there are defenders who argue that the discovery of early massive galaxies suggests a much older universe than previously thought. On the other hand, critics argue that these findings may simply be anomalies that do not fit into the existing theoretical framework. These opposing views reflect the ongoing tension in the scientific community between established theories and new evidence that challenges our understanding of the cosmos. The discovery of these early, massive galaxies, which contradict conventional models of galactic evolution, forces us to confront the possibility that our understanding of the universe's history may need a significant revision. At the heart of this debate lies a fundamental question. How do we reconcile new, unexpected discoveries with our existing knowledge of the universe? While the discovery of these 6 galaxies raises doubts about the traditional timeline of cosmic evolution, it also underscores the importance of scientific flexibility. Theories and models, no matter how well established, must always be open to revision in light of new evidence. In science, certainty is often elusive, and what we know today may change as new discoveries emerge. Michio Kaku's open-minded approach to these discoveries exemplifies the spirit of scientific inquiry. Rather than dismissing new findings that challenge established views, Kaku encourages a willingness to embrace uncertainty and consider alternative explanations. This is a hallmark of progress in science. By constantly re-examining the assumptions that underpin our theories, we can advance our understanding of the universe. As the James Webb Space Telescope continues to uncover more data, the scientific community is likely to encounter even more revelations that challenge long-standing assumptions about the cosmos. These discoveries will undoubtedly spark further debates and discussions as researchers work to integrate new insights into the broader framework of cosmological theories. Ultimately, the role of instruments like the JWST is not only to answer questions, but also to ask new ones. Each discovery leads to new puzzles that researchers must solve, pushing the boundaries of human knowledge and offering glimpses of the universe's hidden truths. The 6 massive galaxies discovered by the JWST are just the beginning. As our observational tools become more advanced and our understanding of physics deepens, we may find that the universe is far more complex and fascinating than we ever imagined. In the end, the story of science is one of continual discovery, a never-ending quest to understand the universe. As new questions arise, so too do new opportunities for exploration and growth. Whether these new galaxies ultimately lead to a paradigm shift or simply refine our existing models, they are a reminder that the universe, in all its vastness, still holds many secrets waiting to be uncovered.